me to check yourself though, right?
Yeah, I failed. I'm upset.
You're upset? Tricky. Okay, so I'm going to do it up here. Why am I finding the derivative again? Let's go over, like, what's the point? That gives me what?
The slope of the tangent line.
Slope of the tangent line once I plug something in. Good. Okay, good. And we go, oh. D high.
Oh,
Minus.
Hi. That's a minus,
Hi.
not a plus. D ho.
D ho.
Whole square.
Over. Whole squared. Usually you don't want to
Wait, so what is
expand
that?
this out on the bottom. You
That's-
don't have to almost ever.
So that's
I did.
O D. What is
O
it?
D high. Derivative of x is 1 minus high. Derivative of that is 1, 2 over whole squared. Cool?
How's that 1? Oh, because it's okay, I see.
1, 0, 1. Okay, so I simplify that. What happens? Chop. Nice. Almost never do you have to expand this out on the bottom, I'll tell you that right now. Like I rarely remember expanding a quotient rule on the bottom. It's always nicer to keep it in that compact squared form usually. Not just usually, like almost always. That's nice so you don't have to waste time on it. Okay, so that's f prime.
So F
Once again, the
prime
point of that was f prime of 2 is the slope of our line.
which is negative 1.
It's negative 1. Negative 1 over 1 squared is negative 1. Okay, we've done all the hard work.
Now we
That's
just
the slope.
Put it in the line. Y minus y1, m, x minus x1. By the way, is this the only way I can do my tangent line?
No.
You could always use y equals mx plus b and plug in that way too. This is just my preference. So
That's at least
have to
easier
use
to
one.
make it.
I like, I don't know, this just clicks better with me. Point, line, slope, I like that better. Anyway, y minus 2, the slope's negative 1, x minus 2.
Y equals negative x plus 4.
I forgot it was in there.
And if you graph that on your calculator, let me think, can I do this function real quick here?
Yeah.
Yeah. Got a horizontal asymptote there.
See how you know it's there.
And this goes here, which means that looks like that, which means this looks like this.
How do you know that there's a horizontal asymptote again?
Because I know my pre-calculus well.
Okay.
Hold on, we'll talk. 0.22 is like in here, right? So I'm guessing it's going to look like
Yep.
that. Does that confirm what this looks like?
Yes.
Could this be 4? Could that be a slope of negative 1? Oh, yeah.
Yes.
Do I expect you to be able to do that part real quick like me?
No.
It'd be nice. Do I expect it? No. Okay. Do you need to be able to do that to get a 5?
Probably.
I don't think so.
Yes.
Well, if you can do the math, you don't necessarily.
You need to be able to put in your calculator and do things like that, yeah. Okay. All right, that was a good warm-up. So how about this one? Before I give you the other trig rules,
And
how about this guy? How about if y is negative 3 or 7x? What is y prime or dy dx? Okay, I bet everybody's launching into their quotient rules, right?
We have to do the multiplication first.
Oh, okay, so people were doing that first. Smart. Just make it simpler, right? Make it simpler, make it simpler, make it as simple as possible before you take a derivative, which means should you use a quotient rule? You can, it'll work. That's going to take a lot of time, right? This has one term on the bottom.
So what do you do?
Split it up.
I'll factor out an x.
Just go like this. Quotient rule will certainly work, but if you can avoid it, watch how easy this is going to be. That's negative 9/7, right? What's this? 6/7 x. Follow? Now if that's y, right? I didn't do anything with the derivative yet. How easy is y prime?
That's just 6/7.
0 plus 6/7, just 6/7.
Where
Is it a lot easier that way?
Yes.
So be thinking, can I simplify my functions before I take a derivative? You always want to try to simplify because it'll save you a lot of time. You don't want to use a quotient rule if you don't have to.
So,
There are problems in the
but
book
if you
that
did, you
have
do
to
the
do that
ideals,
specifically,
right? I don't
like
remember that.
20 and
Right, there are. So I like those problems in
Yeah,
the book
there's the
actually.
boxes.
But in the future, you should be able to look at any type of function and say, can I simplify that a little bit to make my life easier if I have to take a derivative or if I have to do this other thing that we're going to learn? Okay? Alrighty. So, there's that. I think we're all tired. I wanted to show you guys the proof of the product rule, but I'm thinking not today.
You know what I woke up this morning doing, Mr. McGee? Trying
What?
to figure out the proof of the product rule.
Did you? Well, we can talk about it together.
I don't think I figured it out, but that was what I was doing in my head when I woke
Kinda
up this
tricky.
morning.
Dude, when I was doing my head
Hey.
this morning crying. School.
Derivative of tangent. I had this on the board. We tried to do it with limits, and we got to a point where we were like, kind of give up.
And then you use the
Then we just used sine over cosine, and it was really easy, right? What was it? Derivative of tangent. Somebody tell me.
secant x squared.
Secant squared of x. Likewise, do you think it'd be any tougher to do the derivative of the cotangent function?
Is it negative cotangent squared of x? Just cotangent squared of x.
Do
Not
that for me,
cotangent.
please. I want you to prove this.
So
There
wait,
are
the co-
patterns in all these derivatives,
The
yes.
cotangent x is on top.
Yes, so how would you think you might do this? I
Is
think
it
I
I'm
might
just gonna
cotangent?
go.
throw out a
Negative
guess and say
cosecant?
cosecant squared.
I
Probably
said,
something like that.
I
yeah.
said negative cosecant.
I just
squared.
guess.
Yeah.
I
I
don't
think
know.
Let's
he
do
wants
it.
us to work it out.
Yeah,
Yeah.
I
I know,
do,
but
so-
I like to guess.
do. If you take the derivative of cotangent, that's the same thing as the derivative of
1 over tangent.
ooh, 1 over tangent.
Cosine over sine.
Let's do it as 1 over tangent. You can do it cosine over sine. Let's try 1 over tangent. Can we do it that way?
I don't
At the
want to
beginning.
do
But I don't want to
that.
write this down if it doesn't work out.
No.
Yeah, me neither.
No, don't do that.
Does it work out or
Don't
no?
do that.
Because if it doesn't, I won't write it
It'll
down.
work out. It's just really.
How would I do it
I
this
feel
way?
like this is going to be a lot longer.
Oh, because then you're gonna just get 1 over sine over cosine.
Quotient rule. O
Oh.
d high
Secant
minus
squared.
Secant.
I d ho over O squared.
I don't see where you got the 1 secant squared
Yeah, me
from.
neither.
Because that's the derivative of the tangent of
So
x.
ho
Oh,
d
yeah.
high
Okay.
Okay.
minus pi d ho.
So how do you find the?
We just learned the derivative of tangent is
Oh, okay.
secant
okay.
squared. We
So you
just
just
learned
knew that. You didn't like. do it
Yeah,
in your head.
I did exactly.
So your cosines are going to cancel.
Yeah. So you get what's left first, correct? Your head.
So 1 over cosine over
Negative
sine over
secant
cosine.
squared. There's Anna's negative.
Equals negative.
And then we could break this down.
Over sine squared.
1 over cosine
Why are you-
squared. Sine squared over cosine squared. Flip.
CS.
Wait, can we just look?
I flipped it. What happens?
1 over
Wait,
sine squared.
why'd you erase that? What was underneath there?
Negative
Oh,
1
hold
over
on.
sine squared.
Tangent squared is under there. Sine squared over cosine squared. So if I
Cosecant
divide it, I flipped
squared.
it. You get negative
Negative
1 over sine
cosecant.
squared, which becomes negative cosecant squared.
You were close.
Who
Proof.
had the best guess?
Is that the hard of a proof?
Sometimes guessing is good.
I could easily have assigned that. You guys could have done it, no problem. Okay.
Isn't it
But I
easier
don't
though
remember
to
my
do it with
identities
the
very
sine
well.
or the cosine over sine? Wouldn't it be
I think it'd be
quicker?
about the same, honestly.
Me either.
Okay. So we've got in our library of derivatives, derivative of cotangent is negative cosecant squared x. Okay, likewise we could show that the derivative of secant, and we also need the derivative of cosecant. What are those? So we should be putting these in the front of our book, or somewhere where we've got our list of derivatives compiled. These are all things we need to memorize for sure. They're derivative identities, aren't they? So derivative of secant turns out that guy is secant x times tangent of x. It's like two things multiplied together. Notice the pattern, these come in pairs. So when we had the derivative of sine, what did we get?
Negative, oh, cosine.
Cosine.
And then cosine is negative sine. So
When
that,
we did cosine, we got negative sine. So in each pair, there's one thing that's positive, one that's negative.
so that one's
For these
gonna
guys,
be-
it's just opposites. Positive and negative with squareds on those ones for tangent, cotangent. So there's obvious patterns here that you can use to help remember. And then this one, what do you think is going to happen? Anybody got a guess on what this is just based on the pattern?
Cosecant x.
Negative
times
cosine. X
Negative.
cotangent x? Or is it against it?
Cosecant x, cotangent x, that's right. So anything with trig has this. Why does this turn out to be like this? Why do we have these patterns? It's not coincidental. It's not like
Because-
someone made them to be that way.
They're all kind of related. Most
In
of
trig,
them
why do we have
can,
so many identities? There's other identities in math. There's just a lot more in trig.
I'm
Why?
not always.
most of them can boil down to just sine or cosine if you
The
really
unit
get
circle.
down to it.
It has to do with the unit circle. Yeah, it has to do with that too, Caitlin. All those functions are cyclical. They repeat themselves, which means understanding them has a lot of cyclicalness and it has a lot of internal pattern. All of trig is like that, whether you use calculus trig or non-calculus trig.
It's easy to remember.
It is nice.
Well, don't erase it.
No. So I thought we'd do 2 examples of these and be done. Okay?
Yes.
But you're going to have all these come up in your problems. And this is the last thing I might put on the quiz, which is now Tuesday. So this assignment is due Tuesday. We're not going to have class.
Why don't we have a class Monday?
And we have
Why won't we have
the
class?
afternoon is all taken up with junk. We've got stuff to do.
Oh, is it?
Oh,
Is that?
Monday?
Monday, yeah, but so we don't have class Monday.
What on earth is happening on Monday?
It's that
Purple-
survival.
Surprise.
Oh,
that's it.
that.
It's the only logical
What
explanation.
information do you want from me? I forgot. I read your email, but how vague or specific?
It'd be best if you could give me specific, but for not one kid, just for what you
specific.
do in like a class. Like when I do it, I do for each class. I mean,
Okay.
sometimes I do something specific for a kid, but
Right.
I do for like calculus, kids in calculus have these, kids in pre-calc have these, kids in algebra 2 have these. And then I go and address each one of those categories. But
Categories.
there were like the 7, and I mentioned what they were, like higher level thinking, increasing the rate of acquisition of.
Should I know these categories?
No, but they're in that email.
They are in the email?
Yeah,
Oh, then I didn't read enough.
it's kind of the beginning. I say like talk about how you would do higher level thinking, how you would
Okay,
do.
'cause I'm like,
And if you don't cover all the categories, it's fine. That-
check. All right.
Wait, hold on, I'm almost done. I
I'm
messed
on
up,
it.
so I don't
Thank
read
you
it.
though.
I'm sorry,
So-
Caitlin.
What?
Another Caitlin.
Oh, are you still upset about dinner? No? Something else now?
She just yelled at me because I'm not fast enough.
Okay,
apparently.
can you guys try that one? Take the derivative, please.
Sorry.
And we'll do one more.
Shit is in your head.
Sorry, Brett.
That's okay.
I'll do this one for you. I love these things. This is like one of my. This is like the first time I started enjoying math, honestly. Was doing derivatives. I don't know why. I thought it was so much fun. It's like
Oh,
patterns.
so
It's like a
you teach
pattern
that
game all built together, and then it's used for powerful stuff. I don't know. I just thought that was really cool.
And then you just distribute that?
So we have a whole chapter of applications. What are these used for? We know tangent lines, but what else? All kinds of things.
We'll find out all kinds of things later.
Yeah, you see some. You see just a little
Oh,
bit
you were
this year.
his tangent.
We have time for a
And
couple
then you
more.
wrote
It's
one
pretty
over
simple.
sine.
Wait, no.
This is X.
Sorry, this is awesome. This is one over
It's
cosine.
cosine. Sine over cosine. That equals then.
Well, it's sin x over
It's sine
Tangent.
So it'd be, wait, so it'd be, but it'd be sine
But x
x,
tangent
no, it'd be
x.
x times sine x over cosine x squared.
What? No. Because
Yeah,
they share the same denominator.
But you're
You just multiply the
multiplying.
top.
I think, yeah.
Well, he's doing algebra,
Okay.
so.
What? Oh, it's the Heidi Ho thing, isn't it?
No.
Product
But
rule.
the derivative of
I don't understand that
I do that.
Let's pretend this is function h. And let's pretend this is function k. Alright? Or would you guys prefer something cozier? G. The purple's dead about. Okay. So I went h. Then what'd I do?
Times derivative of g.
Times derivative of other thing.
Times
Product rule
G
says then you
times
gotta
G
go
plus.
plus.
Times the 8.
Excellent. So then I went G, I left G alone. Notice, G is left alone and G is primed. H is left alone and H is primed. Okay? That's where that stuff came from.
So,
Could you simplify this? I think if we were going to do something with this in calculus, we'd probably have to like factor because it's got multiple terms. So I would personally factor what out?
I pulled the secant.
I got x sine of x. plus
Because you can
cosine
get secant of x, 1 plus x tangent of x in there. But you didn't put it over it. Alright.
I didn't. I don't like quotient rules. So
What?
you might want to do that. You'll see why soon.
I have a question.
When you see something in common, it's always...
Don't you want to factor
it out.
anyways if you can, just because it looks nicer?
It does look nicer, so it's elegant, but there's a purpose too. You're gonna see that in the next chapter.
How did you,
What else?
hold on, I'm trying to see, I don't see where you got the, so you just took out a secant, right?
Yeah, just pulled it out.
Okay.
So that's left, and that's left. Oh, that's left. That part is gone.
No, that isn't it. Why do you make everything squared?
Okay.
Is it the multiplying one?
Yeah.
That's what we're looking
You
at.
guys are thinking about identity, so I like this. Good. Okay, let's work on this one now,
That
so we can be done.
Damn.
Alright, so g prime, derivative of g with respect to t. We can write that dg dt. What do I have to do here?
Mrs. Mickey, you should change t
Distribute.
into a theta because
Ah,
the theta
Brett says
doesn't
I could
match
distribute, he's right.
I thought there was an easier way.
Well, I don't know if what's easier. Like if you distribute this part when you distribute, it's still gonna be a what?
Like, oh, you have to
Product
just-
rule.
Yeah, you
It's still a product rule. That's how you say that, product rule. Okay, that's still a product rule. So I don't think distributing is really
So-
gonna
so-
help me.
I
Like,
think
that's like
you
F and
take
G?
the
Or H and G or whatever?
Mr.
the
McGee,
original and then
Mr.
the
McGee, currently you
derivative
can't solve it at all because you have t and theta and those are not the same.
Thank you.
I'm sorry, it was bothering me.
You are absolutely correct. Ah, good question. I like this. This is an opportunity for some growth here. Let's pretend I did have t. Don't erase it on your papers. But
It's impossible.
let's just pretend I had t, and you took. We can write this as g d dg dt. What would that be? With respect to t, the derivative is.
0.
Oh.
'Cause
These are
there
all
is
constant.
Yeah.
That's Calc 3 type stuff. That makes sense though, right? You can
Yeah.
understand that. But, thank you, Caitlin, very much. G prime of theta. Okay, so we got a product rule here, just like Austin said. He said I got the, like the
Wait,
HG
what
thing
is the
going.
product rule? Because I thought I had them all written down, but I'm not seeing this one.
When you take the derivative
f of x,
A-
g prime of x plus f prime of x, g of x.
you get f g prime. I'm not even going to write the x's. Plus g f prime. Does it matter what order you do those things in? No. Like you could say g prime f, f prime g. It doesn't matter.
Because it's a plus.
Plus. Quotient rule is the real sticky one. Which is why we like to avoid it.
If at all possible.
Yes. Okay. So this guy, I'm gonna leave it
1
alone.
times tangent of x.
Then I'm gonna take the derivative, secant squared. Yep. Plus, I'm still not even touching this.
1.
Let's hover our
times
hand over
tangent
this.
of x.
plus tangent of x, leave it
Theta.
alone. Tangent of theta. Tangent of theta times, Kate says 1, where are you getting that 1 from, Kate?
One goes to
0 and
one.
1, excellent.
Oh, okay.
There's the product rule, am I done?
You have to add the minus 3
Minus
negative
3
cosecant.
times.
Or plus, yeah.
Oh, I
What's the
did it.
derivative of cosecants right here?
So it'd be plus
Negative.
3.
Negative negative is going to be plus, we've still got a 3. So we've got a
Cosecant
cosecant
x.
theta,
Or theta.
cotangent theta. Now, we might be able to simplify that. I'm just going to step back for a second.
Can't. I pulled it out. You can't simplify that, I don't think.
Not unless you use like an identity on this part. Remember we had
That's
secant
the
squared is 1
tangent.
plus
One
tangent
plus
squared.
tangent.
Maybe that would be a way to go, depending on what you need to do with it. We're going to leave it. Okay? Questions? More questions? Okay, so we got these 4 new ones. We're running out of new derivatives. I think we still have logarithms to differentiate.
Times
Exponentials.
because that's the derivative of tangent. Because you like add.
That's almost it.
Multiply times the derivative of g plus.
Oh,
give you
and
g
the inverse
times the derivative.
functions. That's it. So we're almost done with the derivatives. How do we take second and third derivatives? It's easy. We already talked about it, so that's not gonna be